Hello everyone, and welcome to our notes on 12.1 measures of central tendency and dot plots. And so we're going to look at the different measures of central tendency, mean, median, mode, and range today. But those measures are going to be a summary statistic that represents the middle or typical value of a data set. And so we're just looking at summaries, a summary statistic, and it represents the middle or typical value. So what is a mean? Let's look at the mean first. The mean is just going to be your average. So that's another word for mean, is the average. It is found by dividing the sum of the total amount of data points. So what you do is you add them all together. I call this one the mean one because you have to type them all in. You add them all up, and then you divide by your number of entries of data. And so like y'all do this a lot with your test scores. You add them together and divide by the number of test scores. Okay, so what is a median? Oh goodness, that is not a highlighter. What is a median? A median is going to be the middle. Another word for median is middle. It's the middle number when it's arranged in ascending order from the lowest number to the highest number. And so if you started driving, you know what a median is on the interstate. The median is like that concrete blocker that keeps these 3 lanes of traffic that are all going this way from hitting the people or crashing into the people if there is a wreck that are going this way. Okay, so there's 3 lanes on both sides. That middle thing is the median. I always kind of remember this one as well, just because there's like a really famous picture of, I think it's Michael Jordan. It's like a Nike poster, and it shows his wingspan. So it's got his wingspan, and it's like, obviously this is not going to be a great drawing, but it shows his wingspan, and it shows, hey, he's got the same amount of arm length on each side. Apparently he has 5 fingers, there we go, on each side. And so that median is going to be that middle number. So like, let's just say that there were 3 pieces of data on this side. Oh gosh, 3 pieces of data on this side. He would be the median because there would be 3 pieces of data on this side as well. So it's going to be that middle number. If it's in between 2 numbers, then you would just, you would circle it. So let's just say I put another number here. It'd be the middle of these 2 pieces of data. So it'd be the average of those 2. Okay, so we'll look at that in a little while, but the median is going to be that middle number when it's arranged in ascending order. Okay, the mode is going to be the one that occurs the most or the most often, most frequently. You can have more than one mode. You can have multiple modes, but it's going to be the piece of data that occurs the most, and it is possible to not have a mode. It could be that none of your data points repeat, and so the number that occurs the most frequently in a data set will be our mode, and then our range, last but not least, our range is going to be, I always think of golf and like how far you can hit the golf ball. The range is going to be the difference, so subtraction, between the largest and smallest numbers in a data set. So you take the biggest number, and you're going to subtract the smallest number. And so like if you're on a golfing range, you're going to hit it off like the tee area. You're going to hit it, and to see how far it went, you would have to look at where you started and then how far it went. So you take the biggest number and you subtract the smallest number. Okay, so the range, we're going to look at that in a little bit too. All right, so mean, median, mode, and range. All of these words are familiar to you, but we're going to start talking about their impact when you add different pieces of data. So let's just start with a review from middle school. It says solve for the indicated values, mean, median, mode, and range. So it says, let me move this piece up. It says that Walker gets hired to work at Andy's. Andy's is a place in Vestavia. He has worked the following amount of hours in 9 weeks. So these are different data points. 40 hours, 25 hours, 33 hours, 38, 38, 24, 50, 28, and 31. The first thing we're going to do to help us out is to put these in ascending order, because I know for some of these pieces, I've got to have them in ascending order. So let's go ahead and write those. In ascending order, the smallest one, let's go, I'm looking at the 2s. Smallest one is 24. So I'm going to cross it out when I'm done with it so I don't accidentally repeat it or lose it. 25 is the next one. Let's go through. Are there any other 2s? There are, yep, 28. Okay, now let's go through the 3s. The smallest 30 number is 31. And then 33. And then 2 38. So 38, 38, cross them both out. And then 40. And then a 50. I always recount and make sure I still have the same amount I started with. So I should have 9 weeks of hours. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So I do have all 9. And so we want to find the average. So how do we find the average, which is the mean? We're going to, this one I call the mean one because you have to take out your calculator and you have to type all this stuff in. So we're going to go 24 plus 25 plus 28. So it takes a while. Plus 31 plus 33 plus 38 plus 38. Make sure I don't miss a number here. And then 40 plus 50. Okay, so that's going to, if I added all those up, that would be 307 divided by the number of weeks, which was 9. So 307 divided by 9, that's going to give me 34.1, about 34.1 hours on average. I always like to kind of see where that would fall. Does that fall somewhere in the middle? It does, okay? That's the average. It should be somewhere near the center, obviously not perfectly in the center because it's going to move around a little bit, and we'll talk about that in a minute. Okay, now let's look for our median, which is actually going to be the true middle. We're going to look for the true middle. So there are 9 numbers. So when I do 9 divided by 2, that gives me 4.5, meaning that that fifth number should be halfway between. So I'm going to go find it. 1, 2, 3, 4, 5. That means right here would be Michael Jordan holding out his wingspan. There should be the same amount of numbers on each side. So 1, 2, 3, 4 on this side, and then 1, 2, 3, 4 numbers on this side. Okay, so what is my median? My median is going to be 33 hours because there's the same amount of data on either side of the 33. Okay, what is my mode? What occurred the most often? Do we have a mode, first of all? Do we have one that occurs more than others? We do. The 38 is the mode. That's going to occur the most. So that's going to be 38 hours. That shift was worked more than once. And let's see the range. The range is going to be my biggest number, which is going to be 50, minus my smallest number, which is 24. 50 hours minus 24 hours is going to give me a total of 26 hours. So I have a span or a range of 26 hours. Okay? So Walker goes on vacation for part of his 10th week. So he says, hey, I'm going to work a 6-hour shift for the 10th week, and then I'm peacing out and I'm going to the beach. Okay, so he has all of these same numbers again, but this time we've got 24, 25, 28. So I'm just copying it from before, 31, 33, 38, 38, 40, and then 50. So we add in 6 hours. So he works a very, very short shift before he leaves to go. So we're adding in 6 hours. How are the measures affected by this 10th measurement? So in class, we talked about this. I know that you could calculate these and just see if they go up or down or stay the same. But I want y'all to start thinking, how are these impacted by pieces of data when they're either added to the left-hand side and they're smaller, they're added to the middle and they kind of fit in the data, or they're added to the right and they're bigger. And so this piece of data was added on the left. So that's one of the smallest amount of hours he worked. Actually, the smallest amount of hours he worked. So what we're going to do first is we're going to just guess, and this is what we did in class. We voted on what each measure of central tendency will do. Will it increase, decrease, or stay the same? Okay, so if I add in a 6 there, that is going to give me a lower amount. That should lower our mean. That should decrease our mean. What is our median going to do? That pulls it to the left a little bit, and so it's going to be circled around 31 and 33, so it'll be the middle of that. So that should decrease as well. Will it impact my mode at all? Does that impact the 38? It does not, so there should be no change in the mode. And then what is it going to do to my range? Since it's one of the biggest numbers or smallest numbers, it is the smallest number, so that should increase my range because that gives me a wider span from 6 to 50 than from 24 to 50. So now let's actually go through and calculate. I would do this, it would go 307. It's going to be 307 plus 6. It'll be 313 divided by 10 this time. So that's going to be 31.3 hours. So that did, in fact, decrease from 34.1 hours to 31.3 hours. What is my median going to be? Well, my median is going to be, now it's going to be the middle of 31 and 33, which is going to be 32 hours. So that did, in fact, decrease. It didn't decrease a ton, but it did decrease. And then what is my range going to be? Well, my range is now going to be 50 minus 6, which is going to give me 44, a range of 44 hours. That increased a decent bit. So that really, really, really impacted my range. If I added a number in between the 24 and the 50, the range would not be impacted. And of course, the mode had no change on this problem. All right, so we're going to start talking about outliers. And so we talked in class a little bit today about how if you were looking at the stats of a basketball player and he's scoring like 15 plus points per game, but all of a sudden one week he only scores 2 points. Maybe he scored 2 points in the first minute or two and then he got hurt and had to sit out the rest of the game. Well, that would be an outlier. That is not what would normally happen in a game for him because if he was injured, he's being taken out of the game and he can't play anymore. And so we have extreme values, whether they're low or high, that differ than most other data points in a set. That is called an outlier. So let's look at what that does to the data distribution. If you have outliers that are smaller, that are happening over here, I kind of think of like this like a game of tug of war. If you have outliers on this side, that is going to pull this symmetric distribution. So here's symmetric. It is symmetric if the mean and the median are really, really close to each other. So we're not going to say equal, but we're going to say if they're about the same, it's going to be pretty symmetric. If you find your average and your mean and your median are about the same, it's symmetric. So what makes it skewed left? Well, that's when you drop in outliers over here. So I always think of it like tug of war. Those outliers are going to pull your mean down, and so your mean is going to be smaller than your median there. And so that is going to be where the mean is smaller than the median. That is where your outlier is smaller, so that's going to bring your average down. So think about it like getting a low grade on a test. That's going to bring your average down. Well, what if you drop in some bigger pieces? Outlier is bigger than the rest of the data. So we come in and we rock a few tests. What is that going to do? Well, that is going to pull this tail. You look at it like the tail. The skew is on the side of the tail. That is going to bring my mean up, and then my median is going to be smaller. So if your, let's do that. So if your mean is bigger than your median, then that means that this is skewed right. So if the tail is on the left, it's skewed left. If the tail is on the right, it's skewed right. And then it's symmetric if the mean and the median are pretty close. So let's look at this. People get confused on this because they want to look like the side of the hump, like on the camel's back, is on the right, but the tail is on the left. So it's skewed on the side of the tail. All right, determine the distribution of the data given the following information. So if our mean is 30 and our median is 37, well, that means that our median is greater than our mean, because 37 compared to 30, 37 is greater. And so what this is saying is that the median is greater than the mean. So that means that our, M-E-A-N, there we go. And so that means that our average has been pulled down by our outliers, which means that this is going to be skewed left. Skewed left. Our tail would be on the left side. Okay, now we actually want to calculate our mean and our median. So what is our mean compared to our median? Our mean is going to be all of these added together divided by 4. So 3 plus 5 plus 7 plus 23 is 38. Divided by 4 is going to give me 9.5 for my mean. Let's find my median. The median is going to be this is already in ascending order. It's going to be the middle of these two. The middle of 5 and 7 is going to be 6. So since our mean is greater than our median, that means that our outliers are on the right-hand side, which is pulling the tail to the right. It's kind of like tug of war. The right-hand side is winning. That is going to be skewed right, because our average was brought up by those outliers. Skewed right. Okay? All right, now let's look at it from a picture. So we're going to look at this curve. Our mean is less than our median on this problem. So there is our, let me see how I color-coded this earlier. Here is our median. Here is our mean. So our average has been brought down, and so this part of the tail is longer. This is like tug of war. So this is going to be skewed left. Skewed left. There's some outliers over here that are pulling this rope to the left. Okay, so it's bringing our average down. All right, so how do you pick them? So hold on, this is not supposed to be on here. There we go. That's from my last class. I'm sorry, y'all. How to pick which measure of central tendency to use. If it is symmetric, that bell curve that we're looking at on the other side, you're going to prefer to use the average, just the mean. The mean is preferred or the average is preferred. So here's an example. Donations are collected for the VHHS bowling team. Coach Fern collects 7 donations. Here's the amounts: 106, 100, 85, 200, 172, 90, and 150. None of those are too far apart from each other. Like, we've got a pretty even spread. While we have a $200 donation, we also have an $85 donation. So those are all close to each other. You could calculate the mean, you could calculate the median, and you would see that those are pretty close, so we're going to use the mean. But if it's skewed either left or right, you're going to prefer to use the median, because it's going to have a larger impact of outliers on a mean than it does a median. So oftentimes, I'll do this when I'm looking at test scores. It could be that somebody comes in and just straight up didn't study for a test, or maybe they haven't taken it yet and I've put a 0 in the grade book to remind them to take it. I'm going to look at my median over my mean, because I'm going to look at what did most of my students do, what is the middle of that where the data is grouped. And so here's an example. In the last several games, Carter scored the following points: 24. Carter was doing good. But then he scored 17, still great. 32, great. 23, great. 20, great. And then all of a sudden, boom, we have an outlier. So this outlier of 2 points, while that's still not bad, obviously he made progress in this game, maybe he hurt himself after the first quarter and he was taken out. Or maybe he hurt himself on the first play. He went up to dunk it, and boom, he made the dunk, but gave him 2 points. But as he fell to the ground, he hurt his ankle. So now he's taken out of the game. Well, I'm going to look at the median of his scores. And that's what he would prefer the scouts to look at as well, because he doesn't want this outlier of a 2 to impact his measure of central tendency. So you're going to use a median for that. And then you're going to use the mode. The mode is going to be used for non-numerical data. So for instance, non-numerical. So Marketing and Entertainment Club at our school wants to order t-shirts. The members respond with the following sizes. So because all of these are sizes, you're not going to have a mean or a median or a range. You're just going to have a mode for non-numerical data. Another example would be like if you're looking at people's favorite Starburst color. That would be, you would look at the mode, which obviously pink is best. Personal opinion. All right, so here we go. Dot plots. Y'all did dot plots in middle school, but it's just going to give you a graphic. It's a quick way to display data using dots. So here's an example. Aiden times how long it takes his friends to eat their lunch, and the data is shown below. So from 1 minute all the way up to 10 minutes, and then let's see how many people were interviewed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there were 19 total students that he interviewed, or that he asked how long it took to eat their lunch. Obviously, you know, at the freshman campus, we have a really short lunch, so y'all know y'all got to eat fast after standing in the line. How many students took 8 or more minutes? So we do include the dots that are on 8, since it says 8 or more. So how many are there? How many are there? That's a weird way to say that. 1, 2, 3, 4, 5, 6, 7. So there are 7 students. So how many? We would say 7. Okay. Now it says what percentage ate their lunch in 5 minutes or less. I'm going to underline that. So I do include the 5-minute people. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 8 out of 19. How do I turn that into a percentage? I divide it, and then I take that amount and multiply it by 100. That is going to give me about 42%. So about 42% scarfed down their lunch in 5 minutes or less. Now, what is the average time it took? That's where you have to add them all up and divide by 19. So let's add them all up. 1 minute plus 2 minutes plus 2 minutes. There's only one student that did 3 minutes. Plus 4 plus 4 plus 4. Plus 5 plus 6 plus 6 plus 6 plus 6. And then we got no 7s. So I'm going to skip that one. I'm going to go plus 8 plus 9 plus 9 plus 9. That's why I call it the mean one. Plus 10 plus 10. Whoop! Gives me 112. So it's going to be 112 divided by 19. And I get an average of about 5.9 minutes. 5.9 minutes is my average. So what is my median? Well, if there are 19 students, to find the middle, I'm going to do 19 divided by 2. It's going to give me 9.5. So my 10th data point should be the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be the middle, the median. So that's going to be 6. Let's circle it. That is our median. Means there's the same amount of dots on the right that they're on their left. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So our median is going to be 6 minutes. So that is really, really, really close to my average, 5.9 versus 6. So what is my distribution going to look like? It is going to be pretty symmetric. Because those are so close, comparing those two, because those are so close, that's going to be pretty symmetric. Maybe not perfect, but pretty symmetric. So we're going to use our mean for the measure of central tendency to look at. You can look at both, but the mean is going to be most reliable. All right. This next one is a dot plot, and this is a student's test scores in math. And so we're going to lay them out, and I'm going to create a dot plot to show this data. Now, when you create a dot plot, it's kind of like creating a picture. Yours might be a little bit different than mine, and that is totally fine. So we had one score was a 0. So I'm going to skip some space, and then I'm going to count. So I'm going to show that there's kind of some room in between, and then I'm going to count by 5. So 70 was my next one, so I'm going to go 70, 75, 80, 85, 90, 95. There was 100, so I'm going to have to pull that over. Boom. Okay, so let's go ahead and enter my data. Why did I put this one above? I don't know. Let me fix that. There we go. All right, so I'm going to use a dot plot, okay? So let's go ahead and highlight it as we go. There's 1, 0. So there's a dot. And then let's go to my C's. I've got 1, 2, 2 70s. So 1, 2. I've got no 75s. Okay, there's my 80. I have one of those. Okay, 85. I have one of those. How many 90s do I have? Oh, I have a lot of 90s. I did good. 90, 90, 90. I got 3 of those. 1, 2, 3. 95. There's just one of those. And then there is 1 100. So There we go. Let me make sure I counted this right. 1, 2, oh gosh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces. Okay, so there's my data. We do want to put a title on it. So what we could say is like grades from this one student. So scores on test or grades on test. Scores on test. Okay, how many students, how many times did the student make a B? So remember, a B is defined as an 80 to an 89. So there's going to be 2 times that they scored a B. What percentage of test grades were higher than an 85? Well, let's just count. 85, does it say higher? We're above an 85, so we do not include. It says we're above an 85. So we're not including the 85. It says it wants the ones that are above it. 1, 2, 3, 4, 5. That is going to be 5 out of, how many do we say? 5 out of 10, which is going to be what percentage? 50%. So half my test scores were bigger than an 85. Okay, what is the average test score? Again, I'd add all these up and I'd divide by 10. So when you do that, you'd go 70 plus 70 plus 80 plus 85 plus 90 plus 90 plus 90. And then we'd get 95 plus 100 plus that 0. It's going to bring it down a decent bit. That's 770. And so it's going to be 770 divided by 10. That is going to bring my average down to 77%. Okay, what is the average test score? 77%. What is the median test score? Well, if there's 10, when I do 10 divided by 2, that's going to give me 5. So 1, 2, 3, 4. That is going to be in between the these two, the 85 and the 90, because then there's 4 on each side. So what is the middle of 85 and 90? That is going to give me a median of 87.5, which is very, very, very different than the average. The median is way bigger than the average. The average is less. So what that means is that this is going to be skewed left. That's going to bring the average way down. So what measure of central tendency would we want to use? We'd want to use our median. Because it might be that maybe that student didn't take that test, or maybe they were caught cheating and they were given a 0. When I'm looking at how do they perform overall as a student, I would want to look at the median. Okay? Because that 0 is going to bring the average way down. Like maybe they made a makeup test and then it gets brought up after they make it up. Okay? Anna asked her friends what pets they have at home. Here are the results. So we've got dogs. So I'm just going to call this pets. We've got dogs, cats, rabbits, fish, turtle, cat, and a guinea pig. So I'm going to call that a G pig because I don't have room. Guinea pig. All right, so then we're going to create a dot plot for this. So how many had dogs? And this is what we're going to be dog, 2, 3, 4, 5. There were 5 dogs, so I'm going to put 5 dots there. You could also use X's. Some people use X's on this. Cats, 1, 2, 3, 4 cats. So 1, 2, 3, 4. So this is a really good visual display. Rabbits, how many rabbits did I have? There was a rabbit here and no more rabbits, so just the 1 rabbit. And then fish, 1, 2 fish. What about my turtles? My turtles were, how many of those do we have? Turtles, 2 turtles, 1, 2. And then I have my G pig, my guinea pig, just 1 of those, okay? And so how many, let's go ahead and we have 15 responses total. Let me make sure I counted that right. 5, 9, 10, 11, 12, 13, 14. 15 responses. It's going to help me to have that total. And so how many students had a cat? We'd say 4. Just gives you a really quick visual representation. What percentage of friends had a turtle? Well, that is going to be 2 out of 15. 2 divided by 15 is going to give me a percentage of about 13%. Which measure of central tendency could be used? We would have to use the mode here because this is non-numerical data. What is the likelihood of one of her friends having a dog? That's going to be 5 out of 15, which is going to be 33%, 33.3%, about 33%. All right, so your assignment is a Google form, and it's got the information on what you need to get in order to get credit for the assignment. I want y'all working together on this. I want y'all talking about this. I want y'all talking about the data, analyzing the data, and reading these things and making decisions based on what you know to be true about the measure of central tendency and dot plots. Hope you're having a great day.